Okay, so this is section 7.4. We're now going to be solving polynomial equations. We're going to find real zeros. So those are the first few examples. The next examples are going to be, we're going to be talking about this thing called multiplicity. So those will be in a few videos later on in this section. So in this problem it says use a graph, synthetic division, and factoring to find all the roots. So if we look at this, there's no way to factor this. So how do we actually do this? Well, we use technology. And so we have a picture of a graph here. And so if we look, we use this to find our x-intercepts. So I'm looking at this guy right here, and I'm not really sure exactly where that one's at. It looks like it's about -2, but I'm going to trust this one a lot more and say that that looks like right here it's x is equal to 1. So I'm going to use this guy to, in synthetic division, to start breaking down this polynomial. Now, technically, I could use either this one or this one. It doesn't matter which one I use. I'm just more comfortable because I know that that's equal to 1. This one looks like that local max is at -2, but I'm more certain about this, so that's why I'm choosing 1. So what I'm going to do is I'm going to set up the synthetic division. I'm going to list my coefficients. There's no linear term, so don't forget to put that 0 in there. And I'm going to perform the synthetic division. And look at that. It definitely is a solution. So I know one of my solutions is going to be x is equal to 1. So from there, I now have quadratic. And so this guy right here is our constant. This guy is our linear term, and this is our quadratic term. I'm pulling a linear function out of a cubic function, so what's left over is a quadratic. And so now I'm going to factor this. What two numbers multiply to 4, but add to 4? That would be 2 and 2. So my other zeros are -2 and -2. And it did fit what I thought, but I just wasn't comfortable using that piece. So as far as my solutions are concerned, I have the one that I found on the calculator, which is x is equal to 1, and then the -2's. Now, because this guy happens twice, we're going to talk about this a little bit later, we can either call this a double root, or it has a multiplicity of 2. And we'll talk about that in more detail. Look at the behavior of the graph too. The double root bounces off and then comes back up. Notice there's only one 1 and it goes through the 0. When I have 2 of them, it bounces off the 0 and comes back down. And so that's actually a typical behavior for the double root. So what we've done here is we've graphed it because we couldn't factor this piece. So we went ahead and used the graph, found one of the zeros, didn't matter which one we used our synthetic division to get one of them out so it gets to a quadratic, and we can go ahead and factor that. And that's kind of what this section is about, is using all these tools that we've discussed to find solutions of polynomials.